Okay, this is the video for superposition, and this is part one. And superposition is basically, if you have a couple voltage sources, you just turn them on one at a time and analyze them one at a time, and when you get each one, then you add them up, and that's what your answer is going to be. So for this one, what we're going to do is we're going to take this first one, and we're going to say there's going to be no 6 volts, so we put a wire across it and short it out. So what we have is 2K in series with 2K, so that 4K is in parallel with that 4K, which makes that 2K. And then we have the other 4K, and that's the 24 volts. And so we've got 24 volts and 6K, that means it's going to be 4 milliamps. That 4 milliamps, because it's going to divide out in here, this is 4K and this is 4K, so it's going to split 2 and 2 there. Now, if we do the same thing with the 24 volts and short that out, then we have the 6 volts, so we have, we've got this 4K in parallel with this 4K, which again makes it 2K, so we've got this guy 4K, 6 volts, 4K, 6 volt, 4K, and then 2K. So 6 volts divided by 6K is 1 mil. And that 1 mil comes out this way, and again it's going to divide equally, half a mil this way, half a mil that way. So when we take the final, and somehow if we can add them together, if we can get these screens to want to line up here, what you do here is you take this 2K and this 0.5, and they add together since the arrows are going the same way, so that's 2.5. And then here we've got this 2 mil going that way and this 1 mil going that way, so that adds up to 1 mil. And then over here we've got this is 4 mils going this direction, and this is half a mil going the opposite direction, so that adds up in 3.5. Anyway, what we do here, since in this leg, and what we're interested in is finding the voltage at both VA and VB. And in this leg we've got 2.5 milliamps going this way. So 2.5 milliamps across that 2K is going to be 5 volts right there. Across that 5 volts is going to be 10 volts. And so there we have it. The VA is going to be 5 volts, and this is going to be 10 volts. It's going to be VA plus another 5 volts. And to check that circuit, we can do a couple things. So we have 10 volts here, and then we've got 1 mil going through 4K, but it's going in the opposite direction, so that'll be minus 4 volts over there, and so that makes that 6 volts. Going this way, we have 10 volts here, and we have 3.5 mils going this direction across 4K. So that's going to add up to 14 volts. And so we got 10 plus 14 equals 24. And that's the way the circuit works. Now if we look at it with our MultiSim, here's the same circuit again, and here we're going to just look at the voltages here, set it up really quick, and that's 10 volts, and that is 5 volts, and that's the way that works. And one of the things we can do here is real quick is if we make that voltage instead of 6, we'll short it out like we're doing the superposition. And what we'll do is we'll grab another meter and have to rotate them that way, plug them in the circuit, we'll get that thing out of there, and now we'll measure current. And if we run that, we measure that at -4. Now, again, we have this set up a little wrong. It should be 4 milliamps coming out of the negative terminal, but we have that going into the positive lead. Here, if we have it correct, and we would have this out of the negative lead going into the negative terminal, and the positive lead connecting back into here, and that would give us a +4. So that kind of shows what they do individually. And that's it for the first installation of Superposition.